Right, let me talk now about alpha halogenation. Alpha halogenation is the process of putting a bromine on the alpha carbon, that is the carbon next to the C double bond O. As I have discussed earlier, the notation that we're using here is a Greek letter notation that denotes where the carbons are in relation to the C double bond O. So this is going to be the alpha carbon, this will be beta, this will be gamma, etc., as we get further out from the C double bond O. What we're doing here is putting a bromine specifically on the C next to the C double bond O, which is the alpha position. The way this works is that we can start off with what's called a keto form, and keto forms are actually in equilibrium with their enol forms. Now you'll notice I've got two arrows here, a little one and a big one, and what I'm trying to denote with those two arrows is that the big arrow going back here tells us that the reactant is generally in its keto form, actually to the tune of probably like 99% keto and only 1% enol. But it can form in this way with the double bond from the oxygen taking the hydrogen off the C, and then the electrons from the CH forming a double bond between the two C's here. Now generally speaking, it's known that enols are more reactive, the more reactive form than the keto form, and it's the enol form that's actually going to react with the Br2. Now when it reacts, what's going to happen is that it's going to form a bond between the bromine and kick out Br negative, and then what can happen is that electrons from the OH bond can come in and reform the C double bond O. Now even though the enol form is only probably 1% of the total reactant, what happens is it reacts with the bromine and then it disappears. After the enol form disappears, the keto form makes more enol form to replace what was lost. This is just an illustration of Le Chatelier's principle that states if you remove, basically it says if you remove a product, the reactant will create more product to replace the product that we took away. And that's what's going on here in each of these cases. So what we get is H plus and Br minus as a product of this process.